Hello there, hello all. Welcome to Learn with Mr. Tamuli. If you are keen to learn, you have found the right tutor. That's me, Mr. Tamuli. Be assured, you will be able to learn thoroughly with Mr. Tamuli. Let me introduce to you someone who is very intelligent and smart. Here comes Subhodip. Subhodip will present this tutorial on my behalf. I am sure you will find Subhodip's presentation very absorbing.
Hello friends. My name is Subhodip. Actually, I am a virtual assistant of Mr. Tamuli. I shall present this tutorial on behalf of Mr. Tamuli. In this series of tutorials, we are learning 6th standard mathematics. This is the tutorial number 3.b for the first chapter of your textbook. The name of the chapter is Knowing Our Numbers. In the previous tutorial, that is in the tutorial number 3.a, we started our discussion about the history of the decimal number system. In this tutorial we shall conclude that discussion. And in the next tutorial we will start learning larger numbers and their place values. But before getting into the main topic of this tutorial, that is the history of the decimal number system, we shall first discuss the significance of number systems in computer technology. And we shall also briefly learn the chronology of creation of the revolutionary device known as personal computer. So without further ado, let's begin our discussion. The personal computer was initially called the microcomputer. Unlike the invention of the electric lamp, the invention of the personal computer or the microcomputer cannot be credited to a single person or even to a certain group of people. After a very long lawsuit spanning over a couple of years, an American federal court in 1973 had put the invention of the computer in public domain. In other words, the court ruled that the invention of the computer was a collective effort of many people and organizations. Like the evolution of the decimal number system, the personal computer is also a culmination of a process of evolution over a period of time. But the computers evolved far too rapidly as compared to the evolution of the decimal number system. The computer embodies a number of innovative and highly advanced technologies. And the machine itself is an assembly of quite a few electronic components, some of which, in themselves, are considered as great inventions. One such high-tech component is the microprocessor. Additionally, to run the machine, some sophisticated systems known as software are built into the device. So the story of the evolution of the computer involves a number of very important people from various fields of science and technology and various walks of life. The story also involves a few prominent educational institutions and business organizations. I intend to upload a separate series of videos covering the fascinating stories of inventions and other developments that led to the creation of the personal computer, which brought about revolutionary changes to our lives. For now, I would just like to tell you that scientists and engineers first developed and manufactured general-purpose computers in the 1950s. Computers that were built during the period from 1950s to 1970s were very large in size. In this image you can see an IBM 360 computer that was introduced in 1964. As you can see in the image, to set up this computer a very large size room was required. Such computers were called mainframes and they were hugely expensive devices. Highly improved versions of the mainframe are still in use, and they are now known as servers. Somewhat smaller size computers known as mini-computers were later developed and introduced in the mid-1970s. In this image you can see a DEC PDP-11 mini-computer which was commercially very successful. Though less expensive than mainframes, mini-computers were still too costly and ordinary people could not afford these computers. Beginning in the late 1970s, microcomputers or personal computers started emerging. As you know, personal computers are desktop-sized devices and at the same time, are quite affordable. You now know that computers have evolved over a period of time. The machine combines a number of highly advanced electronic components such as the microprocessor, the memory devices and systems, such as operating system and application software, etc. Some of the developments that led to the creation of the personal computer along with the subsequent developments related to it, may be termed as the personal computer revolution. Advent of the personal computer brought about revolutionary and unimaginable changes to our lives. You must have heard about Steve Jobs and Bill Gates. Even though they were not involved in any of the major inventions related to computers, they played influential roles in bringing about personal computer revolution, also in upgrading of computing technology and devices. And in the process, they were able to build immensely successful and gigantic business organizations from virtual scratch by dint of their masterly skills, smart thinking and business acumen. You might know that Steve Jobs co-founded Apple along with Stephen Wozniak. In order to start their venture of making and selling microcomputers, Wozniak sold his programmable calculator and Steve Jobs sold his Volkswagen minibus. In the garage of this house in Los Altos, California, where Jobs lived with his parents, they started production of their computing device that was designed by Wozniak. At that time, that is in the year 1976, Jobs was 21 years old and Wozniak was 26. While Wozniak was excellent with his electronics skills, and Jobs, along with being a huge electronics enthusiast, was endowed with great business intellect. On the other hand, co-founders of Microsoft Bill Gates and Paul Allen were whiz kids as far as computer programming was concerned. Bill Gates was also masterful in pushing forward the business interests of Microsoft. Driven by the emerging opportunities in the field of computers, Paul Allen left Washington State University without completing his undergraduate studies. Bill Gates also left his studies at Harvard University while he was a second-year undergraduate student. The first project that Gates and Allen took up was to develop software for the world's first microcomputer, the MIT's Altair 8800. After their initial success, they formed Microsoft in 1975. Both Microsoft and Apple became hugely successful companies, and in less than 10 years the respective founders became multi-millionaires. What is more important is that the personal computer revolution brought about such revolutionary changes to our lives that today computing devices have become like air and water. You just can't imagine life without computing devices. You might know that the binary number system is of very special significance to computers. In the binary number system there are only two digits, 1 and 0. I would like to tell you that the binary number system is nothing but a derivative of the decimal number system. Like the decimal number system, the binary number system is also a positional number system. In other words, the binary number system also uses the place value concept and the concept of zero like the decimal number system. The only difference is that there are 10 digits in the decimal system, whereas in the binary system there are only 2 digits. The 17th-century German mathematician Gottfried Wilhelm Leibniz did extensive work on binary arithmetic. For this, he drew inspiration from ancient Chinese philosophy and mathematical works. The English mathematician of the 19th century George Boole did pioneering work on binary algebra, which is now referred to as Boolean algebra. 20th century scientists and engineers working on developing computers made best use of Leibniz's and Boole's work in the design of their device. Use of the binary number system greatly simplifies the design of a computing device. The microprocessor, which is like the brain of a computer, contains millions of tiny transistors. When a certain transistor switch is in on mode, that is considered a read as 0 by the machine, and when a transistor switch is in off mode, it is read as 1 by the machine. If you want to create a machine capable of doing calculations or computations in the decimal system, you shall have to work out an arrangement of making the machine understand all the 10 digits, that is 0 to 9 of the decimal number system. This requirement will make the design so complicated that it is almost impossible to put together such a device or microprocessor successfully. This is why the binary number system is so important to digital computing devices. The microprocessor of a computer does all the required computations using binary arithmetic and Boolean algebra or logic. However, you need to be mindful of the fact that the binary number system is a subsystem or derivative of the decimal number system. Therefore, in a sense it can be said that had there been no decimal number system, there would not have been a binary number system. And therefore, there would probably have been no computers. On that note, let us now get back to the history of Indian mathematics and the origins of the decimal number system. Earliest evidence of the use of decimal system numerals in India can be traced back to about 2300 years from now. Some numerals of the decimal number system like 1, 4 and 6 are found in the stone inscriptions from the times of the great Indian king Ashoka. These inscriptions date back to the 3rd century BCE. Numerals of the decimal number system inscribed on stone walls of mountains and caves have also been discovered in Naane Ghat and Nasik caves. Naane Ghat is a mountain pass located in the western Ghat mountain range, and is situated about 120 kilometers north of Pune in Maharashtra. Naane Ghat inscriptions date back to the 2nd century BCE. Nasik cave inscriptions are of the period of 1st and 2nd century CE. Let us look at these three images once again. The first image is that of an Ashoka's pillar. The inscriptions found in the great king Ashoka's pillars are known as Ashoka's edicts. As I have already told you, these pillars are from the period of the 3rd century BCE, and in these inscriptions we find some numerals of the decimal system. The second image is that of Naane Ghat inscriptions, which belong to the 2nd century BCE. And the last image is that of Nasik cave inscriptions dating back to 1st and 2nd century CE. In all these inscriptions you can find decimal system numerals. The first evidence in the form of a book or treatise, with regard to use of the decimal number system can be found in the works of Aryabhatta-I. Aryabhatta-I was a great Indian mathematician and astronomer. He was born in 476 CE and lived somewhere near modern-day Patna. We know about at least 2 of his treatises on mathematics and astronomy. The first one is Aryabhatya and the other one is Aryabhatta Siddhanta. The first satellite launched by India in 1975 was named Aryabhatta in his honor. Bhaskara-I, who lived in India in the 7th century CE, was a follower of Aryabhatta-I. His work Aryabhatya Bhasya is a commentary on the Aryabhatya. He was also a great mathematician and astronomer. His treatises Maha Bhaskarya and Laghu Bhaskarya mostly deal with astronomy. From the treatises of Aryabhatta-I and Bhaskara-I it is quite evident that they were masters in the use of the decimal number system, and were well versed in the concept of zero. I would like to tell you that we are referring to these 2 great mathematicians as Aryabhatta-I and Bhaskara-I in order to distinguish them from another 2 mathematicians of the same name who also left their mark in history a couple of centuries later. Aryabhatta-II was a mathematician and astronomer who lived in India in the 10th century CE. He is known for his treatise Maha Siddhanta. But his work is not as influential as that of Aryabhatta-I. On the other hand, Bhaskara-II, who is also referred to as Bhaskara-Acharya, was a very great mathematician. He was born in the year 1114. He was a lineal successor of the 6th century CE mathematician Brahmagupta. Brahmagupta wrote the treatise Brahma Sphuta Siddhanta. The city of Ujjain in present-day Madhya Pradesh used to be the most prominent center of mathematics in ancient India. Both Brahmagupta and Bhaskara-Acharya were leading figures in their times at an ancient astronomical observatory located at Ujjain. Bhaskara-Acharya has at least 4 treatises to his credit: Lilawati, Bija, Ganita, Siddhanta, Siromani and Karana Kautuhala. Here you can see the cover of an English translation of the Lilawati by John Taylor, who was a surgeon of the East India Company. Publisher of this book is Cambridge University Press, United Kingdom. A recent edition of this book is available online for purchase. Even though the name Lilawati doesn't sound anything like mathematics, Lilawati is actually a treatise on arithmetic and geometry. The book is named after the daughter of Bhaskara-Acharya, Lilawati. Bhaskara-Acharya was the first man in the world to have had some knowledge of the fact that any number divided by 0 gives an infinite value, or infinity. Now I would like to show you a chart that I have taken from the Encyclopaedia Britannica's web portal Britannica.com. This chart summarizes the evolution of Hindu Arabic numerals. Here you can see the Brahmi script numerals of the 1st century CE that are found in Naane Ghat and Nasik cave inscriptions. The scripts that are second in timeline are from the 9th century CE. These numerals were inscribed on the walls of the centuries-old Chaturbhuj temple situated in Gwalior, Madhya Pradesh. In the Chaturbhuj temple we find the first inscribed evidence of the use of zero. Next are the 11th century numerals of the decimal system, and these are found in ancient mathematical treatises or books of India and Arabia. Finally, here are the modern numerals of the decimal number system that are in use from the 15th century onwards. This is a concise summary of evolution of the decimal number system and its numerals. Before we move to the last topic of this tutorial, I would like to tell you the names of another 2 great mathematicians of ancient India. And I recommend that you learn and gather more information about these mathematicians from Wikipedia, Britannica, or any other source of your choice. The first name I would like to suggest is that of the 9th century CE mathematician Mahavira. He wrote the treatise named Ganita Sara Sangraha. Please don't confuse Mahavira the mathematician with Mahavira the preacher of Jainism, who lived in the 6th century BCE. The other ancient Indian mathematician that I would like you to learn about is Madhava of Kerala, who was a great 14th century CE mathematician and astronomer. He was the founder of the Kerala School of Mathematics and Astronomy, also called the School of Madhava. We shall now conclude this third tutorial by getting a brief introduction to Roman numerals. There are 7 symbols with which we write numbers in the Romanian method. The first symbol is the English letter I in uppercase. The decimal equivalent of this symbol is the number 1. The second symbol of Roman numerals is the letter V, and its decimal equivalent is 5. The third symbol is X, which represents 10. Most of us are conversant with these 3 symbols of Roman numerals. The remaining 4 symbols are L, C, D, and M. An easy way to remember the last 4 symbols is to remember the term LCD monitor. The symbol L represents 50, C is 100, D is 500, and M represents 1000. Please note that there is no zero in the Romanian method of writing numbers. Let us now look at a few examples of Roman numbers. Let's take the number 8 as our first example. As you can see, there is no single symbol in the Romanian method for the digit 8. There are symbols for 1, 5, and 10. So to write the number 8 we shall use the symbols of 5 and 1. We know that 8 is equal to 5 plus 1, plus 1, plus 1. So the number 8 in Roman is written as VI, I. Let's try and write the number 9 in Roman using a similar rule. We know that 9 is equal to 5 plus 1 plus 1 plus 1 plus 1. So the number 9 in Roman could be written as V, I. Here we are consecutively repeating the symbol I 4 times. But one of the rules of writing Roman numbers is that any symbol cannot be repeated at a stretch for more than 3 times. So to write the number 9 we shall use the symbols of 10 and 1. We know that 9 is equal to 10 minus 1. So in Roman 9 is written as I, X. To indicate minus, I is written on the left hand side of X. Similar to writing 8, the number 12 is written as X, I, in Roman. That is 10 plus 1, plus 1. In order to indicate plus, the symbols of 1 are written on the right hand side of the symbol X. Similarly 30 is written as X. That is 10 plus 10, plus 10. But 40 is written as 50 minus 10, which is X, L, in Roman. Here, L represents 50, and X, as we know, represents 10. Again, to indicate minus, X is written on the left hand side of L. So you have seen that there are a few rules for writing Roman numbers. We shall learn about these rules in detail in a subsequent tutorial. But, please remember that unlike the decimal number system, the Romanian system is not at all convenient for writing larger numbers, and for doing arithmetic. Therefore, this system is not used in our day-to-day applications. So, that is it for tutorial number 3.b. We shall meet again in tutorial number 4, where we shall start dealing with larger numbers like lakhs and crores in the decimal number system.